Hi T-Rex math students. We are currently in problem 2.3, and last week we had talked about the words unit rate and constant of proportionality. Recall that unit rate are things like the amount of money per one pizza or the amount of miles in 1 hour. The constant of proportionality is the constant multiplier. So in the case of the pizza cost, it would be $13 is the constant multiplier or the constant of proportionality, because every time you order an additional pizza, you're going to take that number of pizzas and multiply it by 13. 2 pizzas times 13. 3 pizzas times 13. That constant multiplier is constantly multiplied by the number of pizzas you want. From here, you all filled in a rate table for oranges versus cost, and we talked about 5 oranges costing $1 would be considered a unit rate, and $1 for 5 oranges is the same idea, just expressed in a different order. You could also write these as 5 oranges over $1, or $1 over 5 oranges, and we talked about the importance of using a label, $signs, oranges. The second unit rate that we saw in this table was 1 orange cost 20 cents. That's another example of a unit rate. So right here, 1 orange colon 20 cents, or 20 cents colon 1 orange. And again, you could also write it like this in fraction form if that's better for you, as long as you use your labels, which are key in solving proportions. Let's take a look at the equation that you can use for comparing the number of oranges, n, to the total cost. So in this case right here, if I want to spend $1, I'd substitute 1 in for C, multiply it by my constant multiplier 5, because 5 oranges cost $1. 5 multiplied by 1 gives me 5, which is the number of oranges I could buy for $1. To organize this information, I could think of it as $1 for 5 oranges. I could take any cost C that I want to spend and substitute it in for C. So if I want to spend $2 on oranges, I again am going to multiply it by my constant multiplier of 5 and get an output of 10. So for $2, I would be able to get 10 oranges. So from here, you could also notice that these two ratios are equal, because if I scale up by 2 in the numerator and I scale up by 2 in the denominator, that they are in proportion. You could also think about the cost, C, and the number of oranges, N, a little bit differently, like in this equation, but it still is the same proportional relationship. So in this case, I have N, which is my number of oranges. So if I want to buy 10 oranges, what I can do is I can substitute 10 in for N, divide by 5, and I get 2. So if I spend $2, I can get 10 oranges. Take that same idea, and let's say that I have $20. How many oranges could I get with $20? So if I have $20, what number can I divide by 5 to give me $20? Then N would be 100, because $20 is the same as 100 divided by 5. 100 divided by 5 is 20. So in that case, $20 would give me 100 oranges. And again, those are in proportion. I wrote them a little bit differently, but if I scale up by 10 on the right and I scale up by 10 on the left, that's a proportional relationship. All right, so from here, what if we take our rate table and put it on a coordinate plane where we look at the x-axis versus the y-axis and see if we can figure out any patterns or proportional relationships. So 1 orange would cost 20 cents, 2 oranges 40 cents, 3 oranges 60 cents, 4 oranges 80 cents, and 5 oranges $1. Then you can go ahead and connect the points and you'll notice it makes a line. Notice the line passes through the origin, 0, 0, so this is a proportional relationship. From this graph, we also can notice that the unit rate is right here. So at 1, you get 20 cents. So for every 1 orange, you spend 20 cents. So the unit rate as an ordered pair would be 1, 20 cents. Here's another graphing example that's in part B of problem 2.3. And if we look at it carefully, we'll see a unit rate right here through this ordered pair. The 1 stands for 1 gallon of gasoline. And on 1 gallon of gasoline, the car can travel 30 miles. That can also be written as 30 miles for every 1 gallon. Notice that this graph is a line, but also that it passes through the origin, 0, 0. So again, this shows a proportional relationship. The equation to go along with this would be D equals 30G. 30 is our constant of proportionality, so every time I use up 1 gallon of gasoline, I can go 30 miles. So 1 gallon multiplied by 30 would give me a distance of 30. So let's say I want to travel with 10 gallons of gasoline. I'm going to take that 10 and multiply it by our constant of proportionality, which is 30. 30 multiplied by 10 is 300. So I can get 300 miles if I use 10 gallons of gasoline. Keep in mind that this all ties back to solving a proportion. So if for every 1 gallon I can go 30 miles, then in 10 gallons we said that we would go 300 miles. Well, if you write it as a proportion and keep the units consistent, 1 scaled up by a factor of 10 would mean that 30 would also have to be scaled up by a factor of 10, so that 30 times 10 is 300. So there's multiple ways to think of this, but you want to make sure that you're consistently using a system that works for you, including labeling units, using fractions, okay, using equations, rate tables, or graphs.